So properties of water. Water is the predominant chemical component of all living organisms. So it's the most predominant component. It means that in every living organisms, the component that have a highest percentage in the living system is water. So it occupies a very large percentage. The most chemical reaction in the cell take place in an aqueous environment. So that is why, remember, I told you from the beginning that even metabolic reaction will not take place in the body, because most of these chemical reactions are taking place in an aqueous environment, that is in water. Then hydrogen bond hold the oxygen and hydrogen atoms together in a water molecules. And of course, I think, remember, if you can be able to remember from your basic chemistry, when we said hydrogen bonding is usually a bonding between hydrogen and electronegative element, or the most electronegative element. Of course, we have three most electronegative elements. And one of these electronegative elements, we have oxygen, we have nitrogen, and then we have fluorine. So all these are electronegative elements. So you see, in water, you have hydrogen and oxygen. So since there are hydrogen and oxygen, it means that the bonding that exists between water molecule, or that are found in water molecule between hydrogen and oxygen, is hydrogen bond. So therefore, it's this hydrogen bond that holds the hydrogen and the oxygen together. And then the oxygen of water is the very electronegative, you see, is the very electronegative element, while hydrogen is electropositive. So as a result, water is a dipole and exhibit a slight tendency to dissociate. So since in water you have electronegative element, which is oxygen, and you have electropositive element, so as a result of that, the water is a dipolar. Why is it that it is dipolar? Because the hydrogen have a partial electropositive, while the oxygen have a partial negative charge. So partial positive charge and partial negative, that is why it is considered as a dipolar. So these are some basic properties of water. So what are the biological importance of water? That is what we are going to look at now. What are the biological importance of water? Number one, water is a molecule with electrical charge distribution unequally about its structure, and is referred to as a dipole. Remember, that is what we just discussed, because there is electronegative and there is electropositive. So they are dipolar. So that is why they have dipole, partial positive and partial negative, and it dissociates to produce hydrogen ion and hydroxyl ion. So the strong dipole and high dielectric constant of water enable it to dissolve large quantity of charged compound. So because in these water molecules, they have strong dipole and high dielectric constant. So because of this strong dipole and high electric constant, it makes water to be able to dissolve a large quantities or different types of charged compound. Most of the compound that have charge, water can be able to dissolve it. That is why water is considered as a universal solvent. Then the presence of hydrogen bond also enables water to dissolve many organic molecules that contain functional groups. So at the same time, also, the presence of the hydrogen bond in water molecules make it to dissolve a large or many organic molecules that have functional groups. So you see now, if you ask what are the reasons why water is considered as a universal solvent, there are three reasons. Number one, strong dipoles. Number 2, dielectric constant. And then number 3, hydrogen bonding. And then at the same time, water molecules provide a enabling environment for macromolecules to achieve stable structure in solution. So all these are the biological importance of water molecules. So it actually helps the water to achieve a stable structure, a structure that is highly stable, that is very stable. Okay. You see, we are going to still briefly going to discuss on the acids. As we said, an acid is a substance that dissociates in water to produce hydrogen ion. So it breaks down, produce hydrogen ion. So when hydrogen ion are released, the new solution is set to become acidic. So this is it, because now there is a lot of hydrogen ion that is released into the solution. So it is now considered as acidic solution. So when acid is dissolved in water, it produces hydrogen ion and a conjugate base. So now the acids might dissociate partially. So as I told you, we have different types of acid. We have strong acids. We can classify acid based on their dissociation. So acid can be classified as a strong acid, weak acids. So those acids that are weak acids, they are just partially dissolved. They are partially dissolved in water to produce hydroxonium ion. While those types of acids that strongly or completely dissociate, they actually considered as a strong acid. So in a solution, weak acid establish equilibrium between the proton and its conjugate base. In a solution that is this, and then 2, the equilibrium constant is called the dissociation constant. So what usually happens is that in this kind of situation, whenever you have a substance, like now, look at this one, we have He. He is an acid. So it dissociates in water, then it produces hydrogen ion and A minus. So this A minus is considered as a conjugate acid. So there is always a dissociation constant. And how do we get this dissociation constant? Dissociation constant is just the concentration of products, concentration of products. We have concentration of products divided by concentration of reactants. Concentration of products divided by concentration of reactants. So now, which one is our product and which one is our reactant? So this is a product. This one is our product, and this is our reactant. So how do we get this equilibrium constant? So we now take the concentration of the product. The product here is, look at it, is hydrogen ion, and we have it here. We have A minus, and we have it here. And the reactant is HA and water. So we have HA. But you can ask, why is it that we don't have water here? Because usually the dissociation constant of water is 1. It's 1. So that is why we don't usually put it. So where Ka is the acid dissociation constant. So then base is a compound. Remember, we started talking about the acids. So what is a base? A base is a substance that accepts protons. So it's a proton acceptor. For example, ammonium reacts with proton to produce ammonium ion. Like for example, this is ammonia NH3, NH3. So when this NH3 react with, let's say, HCl, so this ammonia will accept protons to become hydroxonium ion. Sorry, ammonium ion. So you have NH4. plus here because it accepts this proton. So now the next thing that we are going to look at is the calculation of pH, POH, and pKa. But if you have any question, you can ask before you proceed. So now, as I said, we are going to look at how we are going to calculate pH and POH. What is pH? pH is the negative logarithm of hydrogen ion concentration. Look at it. pH is the negative logarithm of hydrogen ion concentration. It is like this. pH is a negative logarithm of hydrogen ion concentration. That is pH. But for the POH, because we are talking about OH, so it's a base or alkali. So it's a negative logarithm of, remember when we said a base, usually it's OH group that is released. So we are now going to have POH. But we have a general formula which says pH. You can get a POH from pH. So there's a formula that said pH plus POH is equal to 14. So this one is also a formula that used in calculating the pH. Okay. So now let's look at this. So a base is a compound. So I think we already defined this. Okay, this is also is the previous slide, so it's clear. So we have example 1 here. We have example 1 here. The question says if hydrogen ion concentration of a solution is 4.2 times 10 raised to the power of -3. Calculate the pH of the solution. So you see here, the concentration of hydrogen ion is already given. And of course, from the formula, this bracket means concentration. So we have pH minus hydrogen ion concentration. So we have our hydrogen ion concentration as 4.2 times 10 to the power of -3. So what you do, you now use 4 table to get the log. So the log of 4, you get the log of 4, which is 0.62. And then you also get the log 10 power -3. And at the end, you have -3. So finally, you are going to have your pH as -2.38. And of course, remember you have negative sign before the log. So you now set minus times minus, then it's plus. So at the end, you have a pH of 2.38. So I think this is not difficult and this is not bad. So log 10 base 10 is 1. Log K base K. So because the log and the base are the same, so it's 1. So any log equals to its base is 1. So when you see log 10, it means that the base is 10, so it's not showing. So if the base is 10, there is no need to write it. And there is also a law that says, let's say log M
Oh, yeah.
power M, power M, log M power P. So according to law of logarithm, this P can now come back to this side and you now multiply it times log M. So all this is just a mathematical rules. So you see now this power come back to this side. So that is what happened here. You see we have first, the log is divided into 2. It's divided into 2. And according to the rules, whenever you have times, you replace it with addition. So plus is the same thing as multiplication. So under logarithm multiplication always means plus. So you can change it to plus. So you see this one is just divided into 2. You have log, look at it, it's just divided into 2. You have log 4 power 2. And this is times, so it will become plus log 10 power minus 3 and then base 10. So you can just press your calculator up for log 4.2, you will get 0.62. And this one will now change to this side. So it's plus, minus times minus, sorry, minus times plus is minus. So that is why after you have this 0.62, so you have minus, you are going to now say minus 3, because this 3 now changed to the sides. So that is how we arrive at this.
Yes, sir.
That is all for today.
Okay.
All right, sir.
Thank you, sir.
Okay.
Okay.
Thank you for the
Thank you.
Thank you, sir.
Okay, bye-bye.
Yeah.
Thank you, sir.
Oh,
Thank you, sir. God bless you.
oh. Mhm.